following data of position x and time t are collected for an object that starts at rest and moves with constant acceleration. The position of the object at t equals 5 seconds is most nearly.
Alright, so to do this question, first of all, the answer is 77 meters. This is our answer. So the basic physics principle that we're using is that velocity is equal to the change in position over time, and then acceleration is equal to change in velocity over time. Alright, now in order to solve this problem, we need to first figure out the change in position. So we can write down the graph real quick just to have a better comparison. Right, so then we can see that the increment of change from each plot, for time at least, is the same. It's only 1 second. But the increment for change in the position is different. So for this one, you see there's a change 3 meters. From 5 to 14, it's 9 meters. From 14 to 29, it becomes 15 meters. So right now we can see a pattern in such a table. So this 3, it represents the average velocity between the interval 0 to 1, because 1 second has elapsed and the total change in x would be 3 meters. You can rewrite this as 3 meters over 1 second equals 3 meters per second. And we can do this for the rest of the intervals. So we can see that a second v is equal to 9 meters per second, and a third v is equal to 15 meters per second. Now we can see that the change in the velocities. So remember, the time interval is still the same. So from here to here, we have a change 6 meters per second. And then from here to here, it's still 6 meters per second. So we can see that since the change in velocity over time is constant, then that means our acceleration must also be constant. We can see this by using any of our intervals. It doesn't matter because all of them have a change of v of 6 meters per second, and then all of them are also 1 second. This gives us an acceleration of 6 meters per second squared. So now we can use this information to extrapolate. We can use this to find our future positions. So for a position at t equals 4, or we'll just call this the 4th time, we can see that the acceleration is still constant. So then our velocity will be equal to 15 plus 6 equals 21 meters per second. And then since our velocity is equal to the change in x over time, we can plug in values. The t is still going to be 1 second. So this is going to be 21 equals delta x over 1. And we can see that delta x is just simply equal to 21 meters. So then let's move our graph over here. At t4, our x is going to be 29 plus 21, and that's equal to 50. This is going to be 50 meters, 4 seconds. And then for t5, we do the same thing. t5 is going to be equal to 21 meters per second plus another 6, because remember, our acceleration is still the same. That's going to be 27 meters per second. And then we can use this to find our change in x again. So v equals delta x over t. 27 equals delta x over 1. So delta x is equal to 27 meters. And so for 5 seconds, time 5 seconds, the x is going to equal to 27 plus the previous, which is 50. And that's going to equal 77 meters. And that's how we arrive at the correct answer.